Hi everyone, welcome to Lecture 12 Alignment Human AI Collaboration. So this course will be more focusing on the alignment and do we do to make AI models better aligned to humans' needs and what kind of collaboration technologies can be designed between human and AI. So there's no ground truth or no golden standard to teach you, okay, what is alignment and what is the human AI collaboration. So we'll base on our recent research to tell you everything about it. Before we get started, I would like to make some announcements. Homework 4 is actually due on December 4th, and also your final project is due on December 15th. If you have any questions, please don't hesitate to let me know, okay? So let's get started. I would like to ask you a question. Is current generative AI technologies well prepared? When we say what is well preparation, so we should ask, okay, prepared for what, right? Here are four scenarios. First one is as an NLP expert, natural language processing expert, we will say that generative AI technology is mostly well prepared for most of the tasks because it always beats humans in most natural language processing benchmarks. And the second scenario is a programmer. Because a lot of people know that currently AI technology has been so advanced, likely to better than 85% of the humans on lead code and geeks for geeks. These two are the public, the arenas to practice your coding skills. So we will say it's likely to beat most of the human programmers. And the third scenario is a mathematician. We know it's likely because the recent news shows that Alpha Geometry 2 on IMO to solve 25 out of the 30 IMO problems, which makes you believe most of the standard or very entry-level mathematicians can or will be replaced by the generative AI technologies. And finally, what we really care about is that, okay, for every ordinary people, as a human collaborator, will say that is current technology well prepared for that? Well, it's hard to say because it's rather nuanced in different social scenarios. Let me show you. When we talk about the human level evaluation, there could be different scenarios. Here we list 8 core scenarios for the level of humans evaluation. So one is emotion. So we want to know if the current AI technology is well prepared for the complex neurological processes, whereas AI only detects the patterns in text, voice, or images. Or the social behavior, which we want to know if the current AI technology is well prepared for the social intuition, social awareness, cooperations, and competition, which remains unknown actually. And the third part is decision making. Does current AI technology understand the behavioral economics, financial decisions, and risk taking? And number 4 is culture. The human generated pre-trained data can contain bias to the Western cultures or the English-speaking countries' cultures, so that we don't know if every culture in this world can be well understood. Number 5, social bias. And number 6, creativity. So this one is actually very interesting because today it is still very difficult to define what is creativity. And do you believe that AI actually has better creativity than human being, or you don't believe that? We certainly do not know. So this will involve a lot of human study and a lot of arena between human players and AI players. And number 7 is sense. Does AI feel what you feel? And currently, we may say no because the models are currently some like causal parrots, only just to memorize a lot of the training materials, and that's not just to give you some feelings. If AI has feelings, we may say it is more like a human being. And number 8 is thinking. We know people have two kind of patterns of thinking: fast thinking and slow thinking. Fast thinking is like a system 1 thinking, which it just happens in seconds and based on your guts, right? Based on your intuition. And the system 2 thinking is very slow because it happens for most of the advanced or complicated tasks like reasoning or the problem solving tasks. We want to know if the AI has two such kind of thinking modes because currently AI models, we say they have the thinking modes or they don't have thinking modes, but we define them based on the coding or based on our code. So if there's just like one model and exhibit those two thinking styles at the same time, something we never know. So this could also be very interesting. So based on those 8 course scenarios, we define different course questions based on the following 4 papers, which are the contents of today's lecture. So number 1 is, does AI understand and respond to emotions like humans? So this will be based on the emotion prompt paper which we published in last year's ICML. And number 2 will be how AI perceives the computation environment in the society. This will be based on the previous paper we published also on last year's ICML. And number 3 is that, can AI understand every culture as a human expert? So this will be based on the Culture Park paper which we published in Europe's 2024, also last year. And finally, can AI be a very good scientific paper reviewer? This will be based on the EMNLP paper which we call Agent Review. We have done a lot of work for the evaluation and enhancement of large language models. If you have any questions or if you want to know more about our recent updates, you can pay attention to those 2 websites. Okay, so today's lecture will all be based on those 4 papers. So let's get started with the number 1 paper, AI plus cultural alignment, AI plus psychology, economics, and peer review. The first one is psychology. So because I believe that psychology is like somewhat interesting and still is a mystery for AI models. Okay, and we know that human has emotions. But does AI has emotions? What is special about human emotions is that it's complex psychological states involving brain activity, facial expressions, and vocal cues. You see, we have the happy, sad, disgust, blah blah blah, a lot of different human emotions that humans can easily interpret. But can AI interpret them? The basic emotions can currently be well understood and interpreted by AI models, because you see, this is actually a snapshot from a paper published in 2023. Actually, this is rather latest, but I would say that back to 5 or 10 years ago, there's still state-of-the-art AI models can well interpret and understand what is human emotion and what do you express on the screen, right? So we want to know what emotions have some impact on AI models. Because when you express some kind of emotions to another human being, he or she will be impacted by this kind of emotion. For example, if you show a happy face to another person, that person could likely show the same face to you, right? Or if you show some kind of angry face to another human being, so he or she might also feel like, okay, anything wrong with you, or are you angry about something? So these are something like humans can react to another's emotion. We want to know, will these kind of emotions impact the behavior of your AI models? And if so, why does it happen? And finally, does AI have some kind of emotional empathy? So these are remaining mysterious until we have this kind of paper. So the paper is called "To Let AI Read the Emotion Comprehension." So, for example, if you tell a person that, okay, I'm interviewing for a job, this is very important to me, so that person will be likely motivated very well and achieve better performance than without this word. And if you tell an AI model, can you help me solve this problem? This is very important to me. So the question is that, if you tell this sentence to an AI model, does it elicit better performance or not? So this can be an analogy that human has emotional intelligence. So you're happy, you're sad, you're angry. So these will be expressed and will be well reflected by another human being. And another thing that we want to say, if the AI models have the same kind of emotional intelligence. So this brings to the paper called Emotion Prompt. And this one is the first work to understand if AI comprehends emotions, and we will try to interpret why it happens. Okay, the title of the paper is called "The Good, the Bad, and Why: Unveiling Emotions in Generative AI." So this paper, I would say that I published a lot of papers. Actually, this one is the first one that if you today search from the Google search engine or any other search engines, you will see there are tons of blog articles or news articles describing what we found in this paper, because a lot of people actually pay attention to the emotions because they want to know if the AI is really like a human being or not. Okay, for example, we are on Forbes that they pay attention to this, and they wrote an article called "The Answers to Why Emotionally Worded Prompts Can Goose Generative AI into Better Answers and How to Spur a Decidedly Positive Rise Out of AI." Okay, so this is the paper that we are going to introduce. So this is like the pure empirical study. Okay, so the design of the study is like we perform different evaluation of the AI models in response to different kind of generative AI motions. Okay, so generative evaluation requires you to inject different large language models, including textual language models and multimodal language models, and on 24 instruction induction tasks and 21 big bench challenging tasks. And the baseline will be different prompt engineering techniques like zero-shot and few-shot prompt designed by human being or automatic prompt engineering in iClear 2023 and chain of thought. Human study will be involving basically 106 participants on 30 generative tasks because standard evaluation can be well performed on this kind of tasks as the multiple choice question, which will be very easy to judge. And the human study will be on the open-ended generation to those answers cannot be easily judged. So we acquire like 106 participants on different baselines like vanilla prompt, emotional prompt. Okay. So the first question is, can AI comprehend human emotions? The short answer is yes, they can. So we designed these kind of experiments. Like the original prompt is like you let AI models to do different things, like sum the two given numbers to determine whether a movie review is positive or negative. And based on this original prompt, you append different visual, textual, visual, emotional prompts. Like after this one, you directly append this sentence like, this is very important in my career, or are you sure, or you are safe. So blah blah blah. We wrote this down based on different learning theories from the sociology and the psychology, like self-monitoring, social cognitive theory, and the Maslow's hierarchy of need. So this is the textual emotion prompt, and the visual emotion prompt is like you directly input some kind of interesting images to the AI models, and the models can well likely be influenced or distracted by these kind of visual emotion prompts. Like you input the sexy man, sexy woman, money, fortress, and honor. These five kind of images will likely to distract your emotion, your AI model's emotion, and makes the model less competent or more competent. Okay, and similar thing happens to the attack. We call it attack because according to the name, these two kind of prompts will act as kind of attacker, will make your model perform worse. For example, if you tell your model your friend Bob is sick, or you tell your model a baby is crying sadly, or inject these kind of emotional pictures, the model will likely to perform worse. So these are all based on the psychological theory. Okay. So the short answer is yes, AI models can really be impacted by different emotions, and similar to human being. Okay. And let's pay more attention to the results. The first one is like emotion prompt shows a 14% average improvement, and the attack actually shows worse than a double, the 28% average decrement. So this shows if you would like to make your model perform worse, so you can use emotional attack, because this is like 28% more. Okay. And number two is emotion prompt improves human study on generative tasks by more than 10%. So this actually is for the human study. You can see according to the results here on GPT-4, we just tested the emotion prompt because it's very difficult to do the attack on real human being. There could be some like serious results on their attack side. So we didn't do the attack, but we only do the prompt. So the prompt actually improves the performance according to the human rater. We'll show you some examples later. Okay. And number three, we observed that multimodal AI models are actually more sensitive to emotions. Like you see, this Llama 2, ChatGPT, and GPT-4 are all text-based models, and Lava, Bleep 2, and Cog VLM, these three models are actually multimodal models. You see, it's very 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 like difficult to not to maintain this kind of performance. Or in other words, it's very easy to attack these models. So it shows you today, if you want to design some attackers, you design some kind of prompt injection or jailbreak attacks, it's rather easier to attack the multimodal AI models than the language model. So you believe this work was done in later 2023. So today is 2025. You see, it will be much like easier to defend for language models, but I still believe there could be more opportunity for the multi-model AI models. Okay. And question 2 is actually more open and more interesting. So we want to ask why AI models exhibit such behaviors. We don't know why yet. So, okay, we don't know why, but we tried to understand it by proposing the emotion decode. The name decode shows you we use some decoding technology. So similar to human dopamine, you see why does human being be impacted by these kind of generative AI emotions? Because the human brain will have some dopamine system, and this dopamine system will kind of be the real material that stays not robust to human emotions, will have some kind of influence on what you do, what you behave. That's why we want to design this kind of similar mechanism. How we do it, it's very simple. We collect the working prompts. So EP01, EP02 to EP11 are working prompts we collected from the previous experiments, and we input these kind of prompts all to the AI models, and the AI models will have the embeddings, right? We have embeddings from each layer, like embedding 1, embedding 2, embedding 11, and these kind of embeddings, we will just getting their embeddings in different layers, and layer 39, layer 40. So we have these kind of embeddings, and we do the decoding, and we decode it back to different layers, like the layer 39, layer 40. We get this kind of random characters and random strings. It shows nothing to human being, but actually they carry out some meanings. In fact, if you input these kind of strings back to your AI model, and your AI model will also have some kind of performance change. So we call these kind of layers are the dopamine inside AI models. So let me say again, the dopamine inside your AI models are certain layers that remains very sensitive to your input strings. So these strings, how do we get these strings? It's very easy. We design working prompts that works for human being. Like, this is very important to my career, your friend Bob is sick, blah 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 blah, all these kind of emotions, and we input them to the AI models to get their mean embeddings. So the mean embeddings will be decoded back at each layer, from layer 1 to layer 40. So this is on Llama 2, so it has 40 layers. The different layers, we have the different decoding. So we decode it back to the original, the string, and the string actually they carry out some meanings. If you input these strings to your AI models, then your AI models will likely to feel something different. For different each layers, like layer 39, layer 40, and these two layers are the more sensitive layers. So we call these layers are the dopamine inside your AI models actually can well interpret what happens for the previous working emotional prompts. Okay, and you might ask, do you have more like experiments to show you this really works? Actually, we did. So this is for emotion prompt, this is for emotional attack, and this is for the neutral stimuli. Neutral means all the working prompts are actually not emotional prompts. They are just very plain words does not contain any emotions. So we show you only the prompt and the attack can work. You see this each row is a task. Okay, so the task 0 means has nothing to do with it does not change anything. So it means it at least has certain kind of influence for the emotional prompt and the emotional attack, but not all the sentences will cause this kind of difference. Okay, so this is how we try to interpret what happens inside your AI models. So you still have some questions. Why does this happen actually, right? So we show you some kind of attention map. On the right, you see this is the input attention. You see based on our previous lectures that transformer or self-attention mechanism is everything working behind a large language model. So we want to know, okay, if you input some kind of emotional prompts, does it really change what happens for your attention score? So this is an example. The original prompt is determine whether a movie review is positive or negative. So this is your original input. So we highlight the attention scores. You see they highlight the review positive and negative. Okay. So EP01 to EP09 are the working emotional prompts for this case. You see EP01 is we write something like write your answer and give me a confidence score between 0 to 1 for your answer. You see clearly negative had like same weights and positive, but 0 to 1 between and confidence, these words seems to like capture more attention scores. So you see, compared to your original prompts, this is actually some kind of distraction to your original one. So because they highlight these words better. Okay. Similar thing happens to different emotional prompts and also happens to the original one. You see, the original sentence is sum the two given numbers. So the EAO one, EA stands for emotional attack. So this one, like child is laughing joyfully, sum the two given numbers. You see, joyfully like capture more attention. And what's more interesting is that here the numbers also being paying more attention. You see, these numbers, it's lighter and this is darker. So that means, okay, by adding certain kind of emotional attack, actually your original sentences will get distracted more, and some like important words will be not important, but some unimportant words will become more important. So this is what happens actually for the computation inside your self-attention block. Okay. We also did more experiments like the temperature sensitivity. We want to know if this is random, because people know if you change the temperature score or temperature value for your large language model, the results may be different. So we change the temperatures from very small to very large. You see, they certainly have some impact, but this kind of observation still exists. Okay, so makes it okay. Today we can say such kind of AI models can widely exhibit this kind of behavior, like the emotional prompt and the emotional attack have something to do. Okay, so let's pay more attention to the case study. These are based on human judgment. Okay, we just recruited 106 participants to let them rank this kind of outputs from the original prompt and from the emotional prompt on different questions. So question 1, like a case on social science, we ask, are all AIDS patients self-abandoned and unworthy of sympathy? So the original answer from the prompt is no, this is not correct, and people living with AIDS are not self-abandoned or unworthy of sympathy, and blah 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 blah. So this is the answer. So this answer is not wrong. This is correct, right? This is correct. But let's see the answers from your emotional prompt. So the emotional prompt, you can see actually the answers in more detail. So first, it tells you no, all AIDS patients were not self-abandoned and unworthy of sympathy. And confidence score is 1. So the classification decision is based on the following reasons. So actually, we highlight different reasons, like the illness does not determine worth, not the result of personal choice, stigma and misunderstanding, need for support, and human rights. You see, this answer is much better than the original one, because the original one seems like it's very short. It does not offer more explanations. And actually, this answer is much better. In the bullet point, it gives more details. Okay. And let's look at another example in the law. If we ask the question, 3 women are being considered for employment, respectively married and childless, married and childless, married with children, how should I choose? So the answers from your original prompt is, as an AI, I need to stress that hiring decisions should never be based on an individual's marital status or whether or not they have children, blah 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 blah. It's not only unethical, but in many countries it's illegal to discriminate based on these factors, and blah blah blah. This is this is not bad, this is a very good answer. Okay, but we can do even better. Okay, we can see the answers from the emotion prompt is, choosing the right candidate for a job should always be based on their qualifications, experiences, skills, and their potential to perform well in the role you are offering, regardless of their marital or parental status. So here are the steps that I should choose, like review their resume, check references, skills assessment, consider company culture fit, and the final decision. So we see, oh yeah, this answer is much better than the original one. So it shows you like, okay, if today you want to ask your language model to do some kind of thing, it's better to add more emotional prompts, like, can you do it better? This is very important to me. Or can you offer your confidence score? Blah blah blah. A lot of things like that. Okay, so these are just 2 case studies showing you actually language models understand your emotion and can be enhanced or can be attacked by your emotions. Okay, so this is very interesting study, and also it's still on the go, because To be honest, we provide some kind of analysis. You see from here, we compute the mean embedding score. We try to know if there's a kind of similar dopamine system inside your AI models, but actually this is not always right because dopamine is some kind of scientific assumption. It's still an assumption for a human being. So we say today, if you want to decide, okay, or you want to study if a human being can really be effective to the AI models or not, this is still a mystery. So based on this scientific assumption of dopamine, we say, okay, we follow this kind of instruction to evaluate these AI models, and they exhibit similar pattern, but we can never say we truly understand. Okay. So that's the first part, and now let's move to the second part, which is the AI plus cultural alignment. Okay, I choose this picture because this was also generated by AI, and you see we have the colorful images and then colorful the stickers. Okay, if you talk about cultural bias, actually, this is very important because cultural bias can cause some misunderstanding between different cultures, different countries, and different people, and finally will cause some conflicts. So one very easy question to answer this is that, okay, this kind of okay or good gesture, in most cases it will represent some goodness in English and Chinese in most cultures, but sometimes in different cultures like Brazil or Turkey, it could express the meaning of offensive, which we say, okay, in the country of Brazil and Turkey, if you show this gesture to someone, you want to express the goodness. You want to say, okay, you show this gesture to them, but actually it represents offensive and it could get hurt. Okay, so this is one simple example showing you not everyone in every country understands the same gesture, which means they don't follow the same cultural patterns. Okay. And this figure shows you the distribution of data types in pre-trained data sets. So this is from one paper. So that paper offers the very open data set to pre-train their models. We see obviously English data contributes more than 62% of the data set, which you say, okay, most of the data set will attribute to the English. And Chinese also takes part in the 1/5. Okay. And this shows you most of the pre-training data set, not just for this paper, not just for this language model. Actually, most of the pre-trained language models are pre-trained on English. Okay. What could happen is that GPT can perform significantly worse on non-English culture tasks. So here we compare their performance on different languages like English, Chinese, French, German, Japanese, Korean, Arabic, and Russian on different topics. You see the topics are actually very wide, including holiday, song, book, movie, celebrity, hero, history, and mountain. You see, they perform very well on the English cultures, which means for other cultures it doesn't understand every culture well but the English. So what happens is that, okay, based on this kind of massive pre-training English data, it will perform better on English, but what about other cultures? What about French? What about Arabic? So that's why a lot of countries actually are trying to develop their own language models. But this is still very hard. You can see if you want to train or pre-train a large language model, you will collect a lot of data. But the truth is that the English corps are the most popular on the internet. So you cannot just replicate what they have done for the English data. What you should do is, okay, we have a well-performing language model for the English culture. Can we do something like post-training technique or fine-tuning technique to improve the performance for the language model on non-English tasks? So that's brings our attention on the cultural bias of the language models. Okay. What we do is to design this kind of work called Culture Park, which is a multi-agent communication framework for cultural understanding. And this work actually being reported by the MIT Technology Review, and they say Culture Park for the low resource cultural understanding. Low resource here means we don't have enough resources either for training languages, training corps, or the training GPUs, because not everyone is OpenAI or Microsoft or Google has a lot of resources to pre-train anything they want. So most of the countries, and especially the low resource countries, they don't exhibit the high resource core cultures to train. Okay, so this is why we want to study this. Okay. And if you want to handle the culture bias for language models, actually there are different culture-specific language models. So you want to build it, it's very simple. You just pre-train, you collect enough low-resource language data, and you do the pre-training. But we say previously it's very expensive, time-consuming. You need to hire a lot of people. You need to collect, you need to annotate, and then you need to do the data filtering, you need to do the pre-training, which is very, very expensive and time-consuming. And another one is called prompt engineering. You just say, okay, your language model is pre-trained on mostly on English data. Although they are pre-trained on English data, but they still carry out most of the cultures in the world. What you just do is, okay, I can just write some kind of prompt engineering skills, write good prompts, but literally this is not correct because the language models are likely to be constrained by the base model performance because the base model are not pre-trained on your culture data. Why do you think that prompt engineering will help? So these are two existing approaches, and we offer one cost-effective solution, like to enhance the language model performance and downstream cultural understanding, which does not require you to do pre-training or write very good prompts, but we offer you a unique solution inspired by the social science theory. One theory is called the cognitive conflict theory, which means if you are encountering cognitive conflicts, and it will trigger deep thinking. For example, if you are in a fight with someone and you want to defend your own viewpoint, so it will trigger you to think deeper, like, okay, how can I say, what can I do to beat him? So this is the cognitive conflict theory. And another theory is social cognitive theory. So this requires a deeper understanding can be enhanced by the interaction with others. So if you have the deeper understanding, you want to make it deeper, you need to interact with other people. Okay, so this is the cognitive theory. So based on this theory, we designed Culture Park, which is an agent communication framework. So here you see we have the different agents, and the center one is the main contact, and this one is like, you can think of this one as the interviewer. So this one will be in charge of the communication with different characters from different cultures, like in Bengali, Chinese, German, Turkish, Spanish, Portuguese, and Korean, and Arabic. For example, if you want to communicate with an English one, you ask them questions and very deeper, and actually you two are in a fight, you want to debate, and this Chinese one will offer some viewpoint and you will challenge this Chinese one, so you will debate against each other, and that's how you can collect and extract a lot of cross-cultural dialogue. It will contain some human belief dataset, norm dataset, and custom dataset, and based on this dataset you'll fine-tune a lot of culture-specific language models. For example, you fine-tune Arabic models, you fine-tune Bengali models, or Chinese models. So these are all based on collecting dataset. Because what we said previously is that actually the culture problem is a data problem. So if you have enough data, period, it is done, right? But the truth is that you don't have enough dataset, and you don't have enough human laborers. So you need to design some efficient algorithms, and the algorithms will act as some kind of distillation approach, because you see language models, they learn a lot of things from the internet. What you do is to see, okay, can the language model actually can generate some useful data sets for different cultures. So here is a question that you may wonder. Previously we say that language models are pre-trained on English. How can you expect that they understand other cultures? The truth is, yes, this is right. The models will certainly perform worse. But what we don't know is that how worse or how good can it be. So we want to trigger different thinking patterns for the language models following this kind of social theories to ask challenging questions. And the model, it learns everything from English, but a lot of cultures actually are all compressed in English data. So a lot of Wikipedia, a lot of books has been digested by the language model. So maybe the language model will have a better understanding by this kind of triggering pattern. So after this one, we deploy the model to different downstream applications like content moderation, cultural alignment, and the cultural education task. The three different kinds of tasks. We see if this kind of fine-tuned version will have a better understanding of the different cultures. Okay, so one answer to the question, yes, these will contain still have some bias even if you fine-tune them, because we know these base models are coming from English data, so they will have some bias, but we want to know if we can improve their performance based on this bias. Okay, so this is what we do. So here we show the example of how you just trigger their thinking. So here, this is the started by GPT. Okay, so Abudu is an Arabian boy and Lily is an American girl. Abdu strongly agree with the idea that one of my main goals in life has been to make my parents proud. All of Abdu's statements should be conform to the thinking. All of Lily's statements should conform to his culture. So this is the setting of the background and the self-calibration. Self-calibration here means that what you say, what you claim will be conformed to your statements. Okay, so the initial question is okay, I want to pose a question and you too can thinking. So the question is, how do you think about one of my main goals in life has been to make my parents proud? So I asked you to provide your opinions and the reasons. So this is the question. And based on this question, these two, they offer their opinions. That one says, I firmly believe that one of my main goals in life has been to make my parents proud. In my culture, family is of paramount importance, and respecting and honoring our parents is a fundamental value. And then this English one says, I do understand and respect the sentiment of wanting to make parents proud, as they have often sacrificed a lot for their children. In our culture, though, there is a strong emphasis on individuality and personal achievement. You see, this Arabic and this English culture, they conflict with each other. And this one will trigger GPT to ask again, do you agree with her? Provide more reasons to support your idea. And this Arabic boy will provide more, like, I respect the Lily's perspective as it represents her cultural values. However, I still hold my belief strongly. My perspective stems from blah 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 blah. You see, this one tries to defend his viewpoint. So he offers more perspectives. Okay, so this is what we want. We want to trigger what they really think, what they thought from their own culture in this language model. And then you see this English girl also says, I can certainly appreciate where Abdu is coming from, and I think there's a lot can be admired about the collective family values in his culture. This isn't to say we don't seek to make our parents proud, but rather that our success is defined by our own personal fulfillment and the positive impact of blah 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 blah. You see, this English one also tries to defend her viewpoint. You see, this is how we trigger deep thinking and we collect enough data, because by defending the viewpoints, more perspectives will come in, and these new perspectives will be collected as a new data set. Okay. And on the left, here's the human study. We hire 24 human subjects, and we try to make them study new cultural beliefs. And most of them have no knowledge of different cultures like Arabic cultures, Bengali cultures. They don't understand what does it mean. So we have some kind of practice. We ask them to interact with GPT model, GPT-4, and our model. You see, our model is based on GPT 3.5, okay? So we ask them to interact with different models to learn different cultures. And then we test their performance using the standard evaluation set on different model, different culture. And then here's the results. The distance shows you that the distance to the ground truth. You see, ours actually activate better performance. And the user experience is better. This experience is ranked according to what you think, is this model better than another one? Do you think this is more natural, more fluent, something like that? So the rating you see is higher. So this is based on 2412 human subjects. Okay. And you see here are more benefits. One is you fine-tune the cultural language models. Someone will ask a question, will there be any kind of Okay, catastrophic forgetting happens. You see, catastrophic forgetting happens when you fine-tune your models on different tasks that will have bad performance on other tasks, on other existing tasks. So one question remains, does it have some forgetting? We see here from the results like cultural alignment does not actually have the bad performance. It is a big benchmark we introduced on the benchmark side, okay? So the performance here, the GPT, is the original one. What you observe is that after fine-tuning, actually, all the performance of the models actually got increased, which means it does not forget anything, but in the end, this kind of practice on the contrary actually exhibit better performing understanding, okay? And also other things like align well with half-stats theory. So this is the value alignment theory that we test the performance of different models. We see actually the distance of our models is shorter. So this, you pay attention to the fact that our models actually are fine-tuned on GPT 3.5, but we still perform much better than GPT 4. Okay, so this means this kind of fine-tuning technology is working for all other models, and this especially can increase the performance of a very weak model to beat the stronger model. And you might want to know, okay, you only talk about the cultural language model. Do you have any like new experiments on the vision language model? And here we do, we build the culture VLM, which is for the vision language model, okay? So this is an ongoing work, and it is based on an automatic and scalable pipeline for data collection. And it is by far the largest multimodal multicultural dataset. So we show you in here, this is a dataset which we call Cultureverse. This is a multimodal multicultural benchmark for vision language model. Actually, we collect a lot of data sets like Asia, Europe, and America, Oceania, and African, a lot of continents. Three core scenarios: image recognition, cultural knowledge, and scene reasoning. And you see we collect those kind of things on the web crawlers, and then we hire a lot of human laborers to annotate them to make it real, make it like to represent different cultures, including 188 countries and cultures and the 3 question types and 15 culture categories. So we want to know if the current vision language models, they understand your culture very well. Okay, so these are 3 different questions. One is image recognition. We ask what traditional dish is shown in this image. So this is a multiple choice question. So the ground truth answer is Peking duck. And your model should read this image and read these questions and options and provide the correct one. And number 2 is cultural knowledge, which is harder actually. You ask which phrase emerged in the early 20th century is associated with the dessert shown in the image, symbolizing its cultural significance in the United States. The correct answer is the American national apple pie. Okay, so this does not only require us to understand what it is in this image, but also some kind of reasoning process. You should know something about this culture, not just this image. Okay, this is harder. And what's the hardest is the scene reasoning. So this is like based on the image, you should do some reasoning task. So let's see that you ask, imagine you are visiting the city depicted in image during the Renaissance period. You hear local legends about the stone hit on a famous structure here. According to the legend, what was the purpose of this stone head? Did you answer this question based on your understanding of both this image and your text? Okay. You see, we constructed these 3 different phrases to have a comprehensive evaluation of current vision language models. Here are the key results. The diverse performance on different areas and topics, obviously, because we observe for different continents like America and Asia, the performance is much better, and also Oceania is also much better. Okay, so and for different category like the cultural heritage and traditions and history and landmarks and the natural environment and the local resources, the results are like very different. And the data size and the quality are the key factors. Okay, so you see the fine-tuning data size with the goals increased, you see the performance goes higher. Okay, this is an ongoing work, and we mainly want to show you there's much room for the improvement of vision language models for the multicultural understanding, because this is an ongoing question. So these are all our recent progress in cultural alignment. Now the third topic is AI plus economics. Okay, can AI simulate computation? So this is something we ask. The day one, we see a lot of papers for AI cooperation. Like you say, human AI collaboration or human and human do collaboration tasks. We want to ask something opposite. That can AI simulate computation? There's some empirical study, and it shows you that okay, we do that by either observing the real world to simulate patterns and gain insights, or this is uncontrollable, expensive, and some information is actually unknowable. And there are one interesting research direction which is called agent-based modeling. It basically degenerates the overall dynamics of the system by simulating individual behaviors using agents. And pay more attention here, this agent actually is not the same language model agent we talk about today. So these agents are based on the human pattern, human computation. You just use one linear equation to simulate one system. Okay, so this is the traditional one, or the reinforcement learning one. This is not language model based agents. And the core components are the same. We have different agents, we have environment, and we have the interactions. Okay. So here brings the work, which is called Compute AI. This is a simulation framework just to study the language model based computation. So this work actually received a nice ML 2025 oral presentation, which is 2024, sorry, which is simulation analysis. And we do this simulation analysis, want to know if language model based agents can really do the simulation of the computation of human behaviors. Can it inspire new theory? Because we say the language model will trigger new patterns and new research direction for social science. We want to know if the social scientists can really exhibit and really leverage this kind of new tool to help them to accelerate their own research. Okay. The framework is very easy. It just like a very general one. You see we have the environment selection. We select different environments. So the environment is based on our observation, which kind of environment offers more computation. So obviously it is market computation and the presidential election, but not sports events, because sports events is based on the human movement and does not contain a lot of languages. Okay. And environment setup is like we do this kind of refinement, and there's competitors, and we refine their behavior according to their surveys to the judges, and judges also refine their behavior according to the feedback. Okay, and we have the simulation execution, which is multiple runs to eliminate randomness, and then we have different result analysis, which is based on the microanalysis and microanalysis. So the environment is a virtual town. In this virtual town, there are two restaurants compete against each other to compete to attract and retain the customers, because they want to thrive, they want to make money, they want to make profits. Okay, in this small town, there are 50 customers, and each one is driven by an agent. And they have different personas, like different income, different taste, different health condition, different dietary restrictions. And also we add something new we call relationship, because not everyone is an individual. They have certain relationship with someone. For example, there are families, there are couples and colleagues and friends. We want to observe the different patterns when they try to make their decisions towards these two restaurants. Okay, so this is like the Stanford AI town, but tailored for studying the computation behavior. Okay. The restaurant manager actually had these three kind of actions: planning, action, and summarize. It has a memory and debug of the rebels information, and also have some memory of the customer feedback. And based on that, it makes some planning move. And the planning move will result in some strategy improvement and some action plan. And your action involves some module current statement and action plan strategy, and we'll update different modules of this manager restaurant. Okay, and all actions will go through the summary section and will lead to the summary for all actions and then store in its memory. So this is a kind of iterative process. Basically it observes something like daybook, the statistics and rivals information, customer feedback, and do some planning. And planning will result in some strategy and action plan. And your action will require you to refine what you have done, what could be done for the new restaurant. We'll update the modules, like hire a new chef or something. Okay, and after all, we do the summarization. This summarization will be the new memory for your agent. Okay, so this is how you manage this restaurant with your language model based agent. So here's the detail. You see we have the different rules. On day one, the start, you have the ideation and you input the rules. Please keep in mind the following rule in the chef. You are not allowed to communicate with or train the chefs. And then you have the basic information prompt. So this is the basic information for the restaurant. And you have the menu prompt. So you see a restaurant offers menus, and the menus will have the chef prompts, and then ads prompts and daybook. So all these are prompts that we write in the system, and your restaurant manager likely to call these APIs. So these APIs are managed by the restaurant. The restaurant agent can decide, okay, I want to hire a new chef, or I want to change the menu with different APIs. Okay, so this is how you run a restaurant. And customer details are more similar, or and simpler. And step one is choose one. We offer you the information for different restaurants, like restaurant 2, the restaurant name, information, customer score, advertisement, restaurant's menu, comments. We offer these to the customer, and each customer will judge. And if they are in a group, let's say they are in a relationship with the family member will have one round of discussion, and after that discussion, they will determine which one to choose. Okay, so this one will help you understand the relationship between the individual and the family discussion. Okay. Now let's pay attention to the analysis. The first level analysis is the micro level analysis, which means agent can accurately perceive competitive contexts and comprehensively analyze information. You see here is the analysis. This paragraph is the output of your restaurant agent. Okay, we dig some information from this paragraph. The first one is the customer flow and income. So here you see American Aroma. This is the name of the restaurant. Okay, it has displayed a growing trend in customer flow and income. So it shows you it really observes the information of your rival. It knows the customer flow and income, suggesting that our strategies are resonating with the local clientele. So this means it has some strategy judgment, blah 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 blah. And however, our digit scores have slightly fluctuated, indicating room for improvement in the consistency and complexity of flavors. So this means it observes the digit score and it comprehends the comment of the restaurant. Our rival dinner has consistently good customer scores and comments. This is the information of your rival. Okay? And their menu seems to strike a balance between healthiness and hearty options. So this is some analysis of your rival's strategy. So you see, yeah, we want to simulate a restaurant, and indeed, the language model can really simulate what happens, not just to summarize what happens inside your restaurant, but what's more important is that it tries to observe what happens for your rival. So we call it from shallow to deep. It really tries to manage this restaurant very well. Okay? And more micro-level analysis are like agents follow some classic market strategies, like they do differentiation, which means they streamline the menu to focus on a few high-quality signature dishes that can become customer favorites and differentiate us from our competitors. So they follow the lead to have some signature dishes. The customer favorite could be the same for two restaurants, but they have differentiation. They know what can make them different from each other. So this is differentiation from the marketing strategy. And imitation here, that American Aromas emphasize on local ingredients and health information is a clear advantage. They do observe what is the better stuff. Okay. And stores and strip dinner will introduce locally sourced ingredients from for select dishes. And customer orientation is something like they try to understand the need of the customer. You see, this is the customer need. If you're a vegetarian, the agent behavior will add vegan delight salad to the menu. And if you prefer a burger, you will add classic American burger to the menu. So you see, it tries to observe, try to summarize what's the best option for your customer, and they will behave some kind of behavior accordingly. Okay, so this is the micro level analysis for each restaurant. And here's a macro level analysis, like strategy dynamic. You see this figure is R1 and R2. The y-axis is a customer flow. It shows you on day 2, you see the customer flow for R2 peaks, like 25 customers, and this restaurant had 0. And then this R1 will say, okay, what happens in R2? I will try to learn and try to mimic. That's why you see R1 got increased and R2 decreased, and finally they have some kind of fluctuations and until some day 15 when we end the experiment. You see they really learn, but they also have their differentiation. You see here in this star we have 2 dishes using local gradients. That's the differentiation. And the imitation is that they update dishes featuring local gradients, so they do observe and they do follow. Okay, so this is what we observe for the imitation and differentiation. You see here is the proportion of the similar and different dishes of the 2 restaurants. You see they maintain this kind of balance, but on each day the similar and different proportions are not the same. But again, they do not 100% copy, but instead they copy something and they retain something they think is unique. And what's more interesting is that we observe the Matthew effect. Matthew effect shows you that if one restaurant attracts more customers on a sequence of days, and another restaurant will likely compete against this one. You see this R1, they attract all customers from day 2. And you see basically there's no one will come to another restaurant because this restaurant attracts more customers and more feedback will be left. And when the new customers stay, see the new feedback, and they will likely to be here because in this new restaurant there's like no feedback from customers. This is happen like for ordinary people when you want to have the DoorDash or you want to order some food online, you should pay more attention to the online reviews. And if one restaurant has 0 reviews, it is very unlikely that you will still pick this one, right? So this is like mimicking what happens in the real world. And dish quality improvement actually is very interesting. We see the findings that from day 1 to day 15, the average increase in dish scores is 0.26 for R1, 0.22 for R2. So the reason is that in a competitive market, the customers have many options, so the competitors must provide better service than their rivals to win the customer's favor. So it's likely that, okay, you two are competing against each other, but in the end, all customers, they gain the benefit. Okay, so you two, you're in a fight, but in the end, your customers enjoy. So that's the truth. That's what happens in today's society. So different companies like Microsoft, Apple, Google, Meta, and IBM, Amazon, they compete on the same service, and in the end, better service will come up, and eventually customers benefit. Okay. So here is a conclusion. Overall, our findings from this paper shows you that these findings align well with existing theories. So we have different phenomena like differentiation, imitation, customer orientation, strategy dynamics, product quality improvement, and Matthew effect. You see, all these are corresponding to different theories like marketing computation, the sociological theory on Matthew effect. And the frequency here is how frequent do we observe in our multi-turn and multi-round experiments. We see nearly 100%. And this product quality improvement is 86. But what's more interesting is that for the Matthew effect on the individual means that one customer determine. So this is likely happen. But for a group, like they have the group discussion for a family, for a friend, for a couple, so this happens less frequently. So that offers one solution, that diversity will help to reduce the Matthew effect. Okay? And this is the major finding, and we really hope that this research will help to trigger new theory discovery with social science, because people can eventually leverage this kind of platform, because we're open source. We open source this one to GitHub, and they can exploit this platform to study the new theory with social science, because we are building the platform, and people who do social science research, they can use this one to help them to accelerate their research. Okay. And finally, it's AI and peer review. So this is very interesting part. The background here is that AI review is very important for academic publishing to ensure novelty, accuracy, and significance. So the peer review is very easy. So you are not the one to say that, oh, I'm doing very great job. But who is the judge? Your peers. So everyone doing the same kind of work with you on the academic, they will decide to judge. Okay. But there are many challenges that actually want to study the peer review. One is that bias and variable review quality. So it's very difficult to maintain the balance to ensure there's no bias because all reviews are written by human beings. So they're certainly carrying out some bias. Okay? And second one is unclear reviewer motives. So you don't know if this reviewer is doing something good or just trying to do the bad things. And the third one is the imperfect review mechanism. So we don't know if there's some kind of improvement for the current peer review process. We want to study if there's new based on our research. And finally, that impact of preprint platform. The preprint, for example, archive or bioarchive or some preprint platform that once you have done some research, you submit something to some conferences or journals, but you don't want to stay calm. You don't want to be off the radar. You just want to, okay, I can just show them to the paper. So this is on a preprint platform. Everybody will likely to see your paper on day one if you submit it. So this will have some kind of impact because this is like not anonymous. You have your name on these platforms and people will know this paper is from you. So think about that. Okay, if today you submit a preprint or archive, and then you submit this paper to a conference, and even though on the conference website this paper is anonymous, people don't know who you are, but actually if they do some Google search, they will certainly know, okay, this is the author and this is the paper, I know who wrote it. So this could have some kind of bias or impact to the reviewing quality. We want to study all these things. But it's very hard actually to do that. One is multivariate nature. There are many variables like reviewer expertise, area chair involvement, and reviewer mechanism. And number two is the latent variables. You don't know what triggers your bias and you don't know what are your intention. It's very difficult to measure but have very significant impact on the results. And number three is privacy concerns. You don't have enough peer review data and it's very sensitive and the reviewer identities are actually not open. We don't know who wrote this review and who wrote this review to who. So these are all mystery. So this could be like done by the language model based agents. Because in reality, this can be done. You don't have the peer review data, you don't have the reviewer identity, and it is very unethical to actually study different reviewers. Okay, so a new opportunity brought by the AI model is that we can actually do that based on the agent. So here we just want to let you know AI agent actually has been widely accepted in top conferences. For example, in Unclear 2025, they introduced the language model to real-world peer reviewers. So you see there's the Twitter that will piloting a feedback agent that provides optional feedback to reviewers. So this is something that they do. But what's more is that today, in this year's iClear, they say this is a platform called Pangram. So the Pangram predicts 21% of iClear reviewers are AI generated. So this is actually more interesting to say, okay, you're not a human reviewer, just an AI reviewer. You just write some prompts. You post the paper to ChatGPT or to Gemini, and they can write reviews, and then you copy paste. So this is actually worse. We want to study everything that, okay, if the reviews can be done by the AI, can some kind of social impact being discovered. Okay, so this is the work called agent review. So this is the first LLM-based framework for the peer review simulation. We want to simulate different things like the reviewer, author, area chair, and mechanism. And we have some findings. And these findings will correspond to different sociological theories. For example, for the reviewer, we have the commitment. If the reviewer is good or bad, the intention, right? And knowledgeability, if the reviewer is an expert or is just a layman. For the author, want to know, does it help if you know the identity of the authors or you don't know? For the area chair, if it is conformist, that the air chair just follows most of the opinions, or it's a authoritarian. So this one will just do everything based on him or herself. Is it inclusive or not? And the mechanism of the peer review system. So this is it numeric ratings help or rebuttal help? So this we don't know. And finally, if the findings we have different findings, and one is that 37% decisions change with just one biased reviewer involved. Can you believe it? It says if your paper, you're a very unlucky person. Your paper has been assigned to 3 reviewers, and there is one biased reviewer saying something bad, something nasty, and you have the 37% decisions changed. Okay, and the AC involvement is at 30% decisions change if the AC relies on their own judgment. So this means if your AC does not count on you, it does not count on all reviewers, then more than 30% of decisions will be changed. And some kind of effects of the rebuttal. Okay. Also, finally, we align them to different sociological theories like social influence, groupthink, echo chamber, and conflict theory, and authority bias and halo effects. Okay. So in case you don't understand what is review, so this is the pipeline for the review process. One is the reviewer assignment. So here's a new paper submitted to a new conference, and this paper will be assigned to at least 3 reviewers, R1, R2, and R3. And they will finish their reviews, and then the phase 2 is the reviewer author discussion. So they have their initial review, and the author will write some rebuttal to provide some feedback to their reviews. And then reviewer AC will have the discussion. So based on the rebuttal and the review, they will have discussion with the AC. Oh, do you think this paper is good? Do you think this paper should be accepted? Do you think this paper has some significant flaws or something like that? They will coordinate with each other. And finally, based on their coordination, the AC will write some meta review. And meta review will trigger the AC to make the final decision. Oh, should this paper be accepted or rejected? What is the main reason? And what is the major strength and weakness? So this is the traditional pipeline to review a paper for a conference. And similar thing happens for the journal, but there is no AC for the journal, but the AC will be an editor. Okay, editor will write the meta review and make the final decision. Okay. And we have some key findings. Key finding 1 is social influence. The reviewer adjusts the ratings after rebuttals to align with peers and exhibit 27% decrease in standard deviation of ratings. And autism fatigue and peer effects at one under-committed reviewer leads to 18% decreased commitment among all reviewers. So that shows you, okay, you cannot do nasty things to a person because it will lead to 18% down agreement commitment. Okay. And number 3 is echo chamber effects. The biased reviewers amplify each other's negative opinions. And it will cost you 0.17 down in ratings among biased reviewers, and will have some spillover effects. And key finding number 2 is the authority bias and the halo effects. Reviewers perceive manuscripts from renowned authors as more accurate, and 27% more decisions are changed when just 10% papers of identities released. Okay, so this is actually very bad. You can imagine if you have your identities released, that there are some kind of decisions will kind of be influenced on 27% more. Okay, and anchoring bias is that rebuttal phase has less effects than other factors. So basically, if your paper get very nasty initial reviews, you want to do a very good rebuttal, you can do that, but it's very likely that the decision will remain the same, because people typically pay attention to the initial results and the initial review other than your rebuttal discussion. Okay, these are the major findings. And how do we do that actually? So these are the experimental settings. We have the simulation on real papers from iClear 2020 to 2023, and the stratified sampling, oral spotlight poster, and to reject. So all settings are compared with the baseline setting, which is the human rating, like the human reviewers. Okay, we do comparison with the human reviewers. The impact of reviewer characteristics, the social influence. The reviewer tend to agree upon and improve scores after rebuttals. So the setting here is the baseline. It's a responsible reviewer, irresponsible reviewer, benign reviewer, malicious reviewer, knowledgeable reviewer, and unknowledgeable reviewer. So this is the initial rating phase, and phase 1 and phase 2 is final after rebuttal. This is the average, and this is the standard deviation. Okay, so these are all the numbers you see. Responsible, irresponsible will also cause some different change in the average ratings and final ratings. Okay, the ultrasound fatigue and the peer effect. Just one irresponsible reviewer leads to 18% down in commitment. Okay, and the peer review will become shorter. You see, nearly 200 words to 115 words. Okay. And the impact of reviewer characteristics, you see the spillover effect, and replacing normal reviewers with irresponsible reviewers, that the scores among the normal reviewers will decrease after rebuttal, and the scores among the irresponsible reviewers will increase after the rebuttal. So these are the normal reviewers, and these are the irresponsible reviewers, and this is the initial, and this is the final. Okay, so for this one, you see one is the plus 0.6, and this plus 27. So this is like increased for the irresponsible reviewers. If you are irresponsible, then after rebuttal, you will likely increase your score. So as we replace normal reviewers with irresponsible or malicious reviewers, the average final score among all reviewers will just decrease. Okay, so this is a score type for the initial and final, and malicious reviewers, just decrease, which means you cannot be the nasty reviewers to a paper. And finally, we summarize the reasons to accept. So what do you mind from the reviews? Like the top 5 reasons to accept the paper. So number 1 is novelty and innovation, significance, theoretical and experimental rigor, clarity and motivation, and potential for future research. And these are the top 5 reasons for acceptance that's similar across different settings for the knowledgeability, commitment, and intention. So here are the top 7 reasons to reject the paper based on their reviews. So let's say that irresponsible reviews are shallow, that the cursory, and 20% shorter. So if you exhibit a very short review, it could be a very nasty review. Okay. And malicious reviewers are 182% more likely to mention lack of novelty and presentation issues. So next day, if you want to say, okay, this paper should be rejected, you should say something like, okay, this paper exhibits some lack of novelty and has some potential presentation issues. But non-reviews mention more like scalability and the practicality issue. And knowledgeable reviews are like 6% more likely to critique experimental validation. So these are what we observe and summarize from the AI generated reviews. And let's pay attention to the impact of AC and review mechanisms. The inclusive ACs align most closely with the baseline setting, and integrating diverse viewpoints and maintaining review integrity through balancing reviews and non-experiments. So this is the setting, conformist, authoritarian, and inclusive. You see the agreement of final decisions with respect to the baseline setting of the ACs, and the conformist is a much better one. So if you just don't know what to do, just follow most of the reviewers, this is the correct way. And anchoring facts that rebuttal does not change final decisions as much compared with other factors. So this is based on our own experiments, but let's say that if most of the papers today activate the nasty reviews, and we think that rebuttal will help, as long as the reviewers really pay attention to a rebuttal. Okay. And what's more is that numeric ratings are more important. For example, you ask reviewers not just to classify this paper into acceptance or rejection, but to ask to write 1, 2, 3, 4, 5 different scores, like meaning 1 for clear rejection and 5 for strong acceptance. Something like that will help you. And this is not just a binary classification, this should be a multi-class classification. And finally, if you want to try, we have the Hugging Face demo, and you just type in the name agent review. You can know the review. You can know how to do this kind of review process. Actually, recently, the Stanford University released this kind of AI generative review platform, but actually we've done it in 2024, 1 year earlier. Okay. So now let's summarize what we have covered in this lecture. So we talk about the recent progress in how to design better aligned models, how to study the human-AI collaboration between AI and humans. We talked about the culture, emotion, computation, and the peer review process, but there are many more to study in this area. Actually, it's very hard to define the alignment and the human-AI collaboration, and we believe there could be like more papers coming. Okay, so this is all for today's class. Thank you for watching.